Alright, another draft physics video production. Anxiety edition. I'm not having a good morning. Anyway, I don't know the reason. It's just the way it is. It's the way my life goes. I have days that don't start very well. Anyway, so a little disappointing, the last video. I thought somebody might catch on and get it, but no, nothing. Anyway, so I'll do some comments and I'll comment on some other things. So I did watch a couple of these science chats, the John Chappell Society, whatever, morning with the tinfoil hatters. They do on Saturdays, and they ought to just stick to physics subjects and then just have a general conversation about the individual different people's perspectives on what's causing certain effects or something. I don't know. Anyway, I would do it differently. Surprise, surprise. Anyway, so, and the Franklin Who guy who whatever moderates, seems to have a reasonably logical, yes, he seems reasonable, but he is, as we all are, not his knowledge base isn't extensive, and he makes a lot of mistakes in saying things that just aren't true, about what the physical evidence is or what the theory proposed was or some other thing. And there's just so much of that in the dissident community, and then so much of that just rolls into this, they just talk out, they just say things, and and say, oh, we've proven Maxwell wrong. So that's an example. So in one of them, and then this newest one, I haven't gotten through it all yet, the Bob guy or Bill guy, Bill I guess, whatever. It just tells these insane stories about how he invented the first dishwasher and the first toaster and he invented everything. And some of the stories are just idiotically preposterous in the sense it talks about having a compression algorithms that somehow created 1,000,000 times compression, and it's not theoretically possible, let alone even imaginable. Most stuff, the thing taking in the information's all kind of important. Most formats of information are not that grotesquely inefficient to start with, and all you're trying to take out is some superfluous patterns and stuff like that, and so you can optimize some of that stuff, but there's no, you can get like 2 to 1 or 5 to 1 or 10 to 1, if there's a lot of redundancy. But it's really, there's no 1,000,000 to 1 possibilities. There's no, and he's saying he did this back in the 80s or something. I mean, just preposterous stories. You're just like, well, why are you wasting time with this crap? I mean, the guy's obviously delusional, and has written a whole story for his life, and it's all preposterous exaggeration. I mean, he actually is proud to be selling some sort of device that tells whether you're alive or dead. I mean, just silly stuff. Well, anyway, I mean, you can't call it science chat when it's really delusional kook chat. So anyway, just a criticism. So one of the things that came up with the Maxwell thing again, so this is just sort of an example of the average dissident and how they approach these problems, and they cheat all over the place. So the presumption is that Maxwell was wrong about something. Now, I think Maxwell was wrong about lots of things in terms of what his personal view of the universe. But the equations are the equations, and they're all stated as generalities in the sense that all the equations have built into them assumptions about, well, you only use this equation if you have a perfect sphere, a perfect one. Then the equation works. But if it's a little bit imperfect, yes, your results will be a little bit imperfect. But it's a little tiny bit imperfect. And so there's things stated that aren't absolute truths. They're just truths for the sake of doing the argument, for doing the experiment, and recognizing that you're not going to have a perfect temperature, and you're not going to have a perfect this and a perfect that. You're not going to be able to idealize. So yes, in ideal circumstances, the equations are more accurate than they are in less than ideal circumstances. And in some cases, some of the stuff has nothing to do with the experiment, so it's irrelevant. It doesn't, you're not, the thing you're trying to find out has nothing to do with the stuff that could be leaking out, but you just say it's irrelevant or it's zero. So anyway, the subject of the coil came up. I can do this quickly, I think. You know, the idea of a solenoid or anything else that has a coil of wire. And this is a favorite thing of the dissidents, because they love electricity and love thinking that this all, you know, that they have some theory of how this induction thing works and how coils work. And so the idea is that Maxwell's equation basically says that, you know, when you run current through this coil, you're going to get a field inside. So if I was to draw it this way, you just imagine there's a coil here and you're looking into it. There's lots of field in here, okay, lots of plus minus magnetism stuff, and nothing out here, okay. Now it's not stated as an absolute statement that there's zero out here. It's just that there's so little, well, zero, there's so little that nobody cares. You know, that it's not enough to do anything. It can't affect much. It's very weak, and it's very strong inside. And the point is, it's very strong inside. I mean, you know, it's a huge magnification of the effect you get when you just have a plain wire. You get a very weak current, and you know, very weak magnetism. You know, north-south kind of effect, or however you're, depending on the voltage you're running, or north-south, you know, however you want to look at it. And clearly the coil, and then when you put matter actually inside here, you know, like a piece of iron, then the effect is even stronger. And as I've sort of pointed out, well, the reason for that is that the coil is a reflector. And see, part of Maxwell's equation is these notions of perfection. So the equation basically says how long is your coil, you know, and it says how thick is your wire, and there's certain things that matter, and they matter because basically what you're trying to do is create a continuous surface of wire. I mean, no air gaps in it, you know. And it would have to be, and kind of perfect in the sense that the wires meet perfectly and all that kind of stuff. And the point is that basically it's a shielding. You know, you're trying to create almost a continuous surface, but, you know, a continuous surface that you're running current through progressively in a direction. And the idea is that inside, I would argue why it's magnified is because you're basically creating an internal surface, and the energy's reflecting inside. So all the effects you create are caught inside the coil and reflect many, 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 many times, where the energy on the outside never reflects. So it just shoots out, doesn't come back. Okay, so it's very dispersed and weak, where the energy inside is very strong because it's constantly trapped inside there, reflecting. And the metal just enhances that process by creating even more reflections, and at a faster rate. And again, it's all about interactions. So as I've tried to emphasize, energy is interactions. And so again, with the two ping pong paddles, right, and the ball bouncing between them, and then I put them closer and the ball bounces faster. The idea is there's more hits here than there is here per second, a lot more. Okay, twice as many. And, you know, depending on how much I cut it down, more than that even in this example. And we have to understand that these hits are at the same momentum each time. So there's no loss of energy in these perfect systems. So, you know, you can just sort of get it that the only thing that's different about these two things isn't the number of things in here, not the amount of force or energy or whatever you want to call it, ether or anything. The difference is the proximity, and that creates what appears to be more energy, but it really just means that you've created more imbalance. But I won't get into that. But the fact is that the interactions are what defines the energy of a system, and obviously reflections create more interactions. It's more stuff to interact with if something is going to keep hitting you. If it's going to just bounce back and hit you again. So if you spit and your spit bounces back in your face and then it leaves again and then bounces back and hits you again, and then you're going to realize that somehow it has a lot more than you thought it did. Its momentum is still alive. It doesn't just leak out and go away somewhere. It's staying inside the system. So anyway, that's what I've tried to emphasize. But anyway, so Maxwell's equations don't deal with this. This is irrelevant. So you can't say, I've proven Maxwell wrong because I've proven there's a tiny bit of a field out here. And there is. And Maxwell knew it, and everybody knew it. So it's not like you can prove somebody wrong when you're claiming there exists something they knew exists. Yeah, they knew it exists. The math doesn't have anything to do with that. The math has to do with what happens inside of here. This is what the math is worried about. The math isn't worried about this. But just an example of, how grandiose the claim is. I've proven Maxwell wrong, when you haven't proven anything really, and you certainly didn't prove anything Maxwell didn't already know. So you didn't really surprise him either. This thing is just not as good as it should be. I complain a lot, but I see other people's marker and it writes. They don't have this problem. But anyway, so just an example. So that's enough of that. We'll do comments. I'll struggle through them. Hey man, you can press K on the keyboard to pause play instead of using the mouse. Hope this helps. Yes, I know that. That's a YouTube thing. YouTube only, pretty much. Which is kind of annoying, just because the spacebar used to work just fine. But of course, I already know all this, so thank you, yes. But that doesn't really help because the keyboard's over there. Yeah. So, for reasons just too hard to explain. Alright, so Tyler, who has his own neurologically challenged, or however we want to say it. We all have our difficulties. And he has some. Anyway. Can you explain physicists' free energy theory? I don't even know what that means, but yes, you mean nutters who have some theory of energy. So maybe that's a thing worth drawing too. What is energy? So I've tried to explain that energy is merely. Let's go back to the electron example, so I can be a little more clear about parts that I'm not terribly happy with in the last video. So the electron, alright, the idea is it gets hit by a force and it reflects the energy, and so right here we should say we're done. That's conservation of energy. Alright, game over. But it really isn't. The game really isn't over, because what happened inside of the electron is that it made an exchange in its interior. I would like to put one more in there. Sorry. Alright, so just pretend this isn't there. Alright, never mind. Imperfections. And I've tried to emphasize the point that's going to happen is that this thing before the impact, it had 2 arrows going this way and 3 arrows going this way, rowers. And what happened here was that, a rower went in here, this guy left, and that's what really happened. So this one that was going this way was replaced by a guy going this way. And now this electron has a 3 to 2, which means it's going to have a little bit of momentum in this direction. The entire electron will move that way. Alright, so this looks like that's the end of the story, but it really isn't, because the electron already has an imbalance in it. And for every electron that was, say, 3 to 2, there's another electron somewhere in the universe, you could argue, or in the field somewhere. That extra rower is there. So he's going this way. So that's the balance here. This plus this then equals balance, 3 to 3. So say in the universe there's an equal number of this and an equal number of that, right? The two in the universe are equal. And all you're really talking about is creating places in the universe, all right, like inside of an electron, where you have this kind of problem. You have a one going that has 4, and this one over here has 4 of these, you know. And so the idea is that the universe is colliding. The forces are going past each other. So the whole universe is just made of these arrows crossing each other all the time, going in all directions. And the idea is that the matter, all right, starts to collect that stuff in imbalanced proportions. If it was perfectly balanced, if it had 3 and 3, which I'm saying electrons can't have because they're odd, they have an odd number of seats in their boat. But if it was 3 and 3, it would just sit, you know, and it have to have 3 and 3 in all the directions. Then it could just sit somewhere. But it won't have 3 and 3 because it only has 5 seats, so it's always going to have 3 and 2, or 2 and 3, or 5 and 1, or some other ratio of an imbalance. So the electron is the imbalanced element, and the proton does have the 6 seats, so it can sit around do nothing, but it can become imbalanced just as easy. So the idea is energy is where you have on one side somewhere, like in the atmosphere, let's say on the planet Earth, or inside an atom even. So inside an atom, you have all this extra energy because you have these electrons that are closer to each other than they want to be, and you have and then you have the proton and the neutrons inside the nucleus. Now they're balanced because they have an electron in there. The neutron provides. So I'm not going to talk about breaking nucleuses. You don't break nucleuses in atom smashers. What you're really letting loose is the pressure between these electrons. And that pressure is allowed to get high. These electrons are closer. That is, there's lots of going back and forth this way, little reflections like inside that coil. And it's basically that energy that you're letting loose when you split this atom into 2 new atoms. Okay, then there's going to be less pressure between the electrons. And so the energy you release is these extra electrons. I mean, extra force between the electrons. But you're really just reducing the pressure. It's all just expansion. You're just making things bigger. And by making them bigger, there's less room for them. They have to push on each other. And so there's a great deal of outside pushing because this compression can no longer be maintained because the pressure going in isn't as strong when you have 2 of these nucleuses. Anyway, I don't want to get into all that. The better example is maybe the thermal example of you have the Earth's surface and it gets the rays come down, it makes it hot, the heat goes up, and the heat ends up having a moisture in it, and the moisture ends up going up because it's hot water, and the vapor, it makes a cloud, and the rain comes back down again, and it comes back down on top of a mountain, and then it flows down to the ocean. And so there's lots of places in here where you can see the imbalance, right? It's an imbalance. You could say that this side has like those electrons, it has a bunch of electrons going in this direction. So you can ride on those. You can jump into that force and be carried up. Or in the case of when they get heavy up here, and they're getting colder, and so they start to get heavier, you know, they're going to fall down because of gravity. And so now you can pick up that change. Now there's going to be more force going this way. It's gravity's pushing down all the time, and these are becoming more and more massive. And so now you can just ride the flow down, and you can steal the energy of gravity. And so you can have hydro, or you could even have you could make a funnel up there in space or something, and catch the rain. Or you up in the atmosphere and catch the rain, and you know, deal with this difference in pressure between here, and the pressure difference is in the form of momentum in a direction. And in this case, the momentum is being supplied mainly by gravity. And in this case, it's buoyancy. It's an anti-gravity device. So the going up is anti-gravity. The going down is gravity. But anyway, the point is they're just imbalances. You're just saying there's 10 of something up here, and there's only 2 of it here, and there's an imbalance, and there's a flow in the imbalance if there's force moving, and you can move something if you put it in that flow. And if you move this thing down, then this thing over here can go up, and you can create a motor, up, down, up, down, up, down, up, down, or something like that. And you can tie that to a piston, and you can make a wheel go around, But energy always is sort of like that, right? I mean, you spin a generator over here, and because the water's flowing over it, and then you spin something over here like a motor to make work. I mean, you can see the equity of the system. And so you're really just taking advantages of imbalances. So over here you have the imbalance of stuff going down. You put a motor in it, and then you can push something up over here. And the idea is to do that efficiently, without losing too much of the energy to places you don't want to lose it. But so the word energy is just a tricky word, but you have to understand it's just places where things are doing something opposite, and they have to be kind of material things. I mean, without the matter, the force can't have any effect. The force forces matter to move, and when matter moves, its force goes with it, so its force pushes on something else. It's a mirror, and it's moving, and as it gets closer to you, you get more and more reflections. Something like that. All right. Energy theory and how particle accelerators work, if you haven't already. Well, you can look that up. I mean, they work by creating a difference in voltage and forcing charged particles, protons or electrons, to jump the voltage and move fast. And then they use magnets to control it so they can put it through again and make it jerk with a little more momentum. They do it again and again, but each time it keeps decelerating. It's the downside. So it starts losing some of that velocity. By the time it gets around again, it's slowed down. And so, that's why it takes so much energy, is because you lose so much of the momentum you create, you lose. It's not, but that's basically the basic idea. They use voltage to cause the movement, and then they use magnets to control direction, essentially. The other trick is to use magnets to compress the thing that's moving, and so if you compress it, you can make it go faster. Alright, thanks. So then a particle accelerator is like LIGO. LIGO's not a particle accelerator. And CERN. So see, I mean, you're just so, I mean, I don't want to diss you, but I gotta really have conversation on a little bit higher level. You have to be a little bit more, you have to be somewhere in the real physics ballpark, not the pseudo physics crapola you heard at your, whatever your I don't know. Trying to think of what's the word they use for that fake medicine, where you take pill, little herbs and stuff. Yeah, this isn't herbology. Thanks. Anyway, CERN, what would happen to the particles if you cause deliberate interference? So this more, I can't explain it to you. There's no real evidence that you can ever cause a force to interfere with a force. That is, you can't shoot 2 flashlights into each other and cause the little light bits to interfere with each other. You can't make it happen. And my whole argument that I've made in these videos is that there is no such thing. The interference pattern is the simplest pattern in the universe, meaning lots of things can create the pattern you would see that would look like an interference pattern. So you can't be fooled that because you see a pattern that looks like interference, it's interference. It's an on-off pattern. Lots of things can make that. And I'm saying, yes, there really is no photon interference. Photons don't split in 2. Photons don't have a wave function. It's all a wrong answer. Like if you could put your hand, so to speak, in their accelerated particles, what would the effect be? Well, the effect would be something like X-rays or something. If you're still getting they're using millions of particles at a time. They can't really accelerate one. Sort of a they sort of misdescribe how they see things. The real technical details aren't really what they have generalized them to for public consumption. But yes, you wouldn't want to be inside an accelerator. You can't be inside one because it's a vacuum and you die anyway, but whatever. I don't know. Alright. Effects be on, say, your hand and the particles. Well, particles are particles. The idea they're matter bits when they have momentum, okay, when they're moving. As I'm stating, they're basically carrying a bunch of force carriers. The electrons all are charged and the protons are charged, and that means they're mirrors to certain kinds of force. And so if you get them closer and closer to you, they're going to force your particles to move. The force is going to hit the force, so to speak. The electron will get closer and closer, and in a sense the force, the power of the pressure, can go to infinity, in the sense that the little bit moving the speed of light between them gets closer and closer. You can sort of say there's sort of like this infinity thing where they can get so close that that little bit is bouncing back and forth at an infinite speed, in the sense that the distance is so small, that the photon could blah, 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 theoretically. In theory, no, because the photon probably has a discrete size, and once you get to that size, then the photon can't move. But who knows what that would, maybe the universe would blow up if that ever happened. So the electrons never really physically hit each other. They hit each other's bubble. They hit each other's airbag, of charge that they're excreting, reflecting. They hit the reflection of the other side, however you want to put it. And so your particles are going to get moved around. And obviously you can sort of imagine that if I move too many of my particles around, if I was made out of like Legos, and I started moving the Legos around, you could sort of understand you could move them enough where the Legos fall apart. And if they pull apart, the whole thing will fall apart. So you might do enough shaking damage to rip your Legos apart and you fall apart. Maybe. Why does the Higgs boson look like a dipole? Well, it doesn't. They never saw a Higgs boson, okay? So the whole thing is, that's really abstract and complex, engineered physics. Really no place for a newbie to be playing around in. I would argue the Higgs boson is not a real thing. It's just an acknowledgement of the existence of this force I was talking about, and the fact that there's always some of it still around and it leaks out of different places. So you could almost argue that when somebody discovers a little bit of a magnetic field outside of a coiled wire, that little bit of a field they're detecting, you could say, whoa, let's call that the Higgs boson. That's the kind of thing they're doing, and it's just wrong and stupid. There was a movie I watched recently. Well, forget about movies, okay? I mean, obviously they're crap. Interstellar was an example. I mean, they don't use real physics in movies. Newsflash. Where they captured a Higgs boson, then shot it with a force, and it expanded and was captured again. Well, it's really not accurate at all. The Higgs boson isn't, in some respects, it's thought of as a field, not really an individual discrete particle. Again, particle physics is about waves. It's wave physics. It really isn't particle physics. I can't help you here. How would that develop free energy? So again, this idea of free energy, I just explained, there's all kinds of imbalances already in the universe. Whenever there's a material object, there's lots of energy to grab out of it. And if it's moving, you can certainly tie a string to it and let it pull the string. But that's all you can do. There's force moving around, and there's imbalances in the force that you can make obvious by the imbalances creating movement in matter. If a piece of matter is moving, it's showing you an imbalance in the field that had existed. And the imbalances are basically created by the fact that so we'll go back to the drawing board real quick, I guess. What's wrong with this thing? Oh, hold on. modem wire. I want you to tear that off, Gary. That'll work. Yeah, much better video that way. Alright. What was I going to show you? Oh, shit. I don't remember. Imbalance. Shit. Oh, fuck. So I know I had. Oh, okay. Here we go. Alright, so the trick is. That didn't erase. That might be why it's not drawing. Yeah, that might be it. I put vinegar on it too, and that usually works, but this time it didn't. It failed to work. Oh, okay, well, this is drawing. Alright, so, I forgot what I was going to do again. Damn, I'm having a bad day. Hopefully it'll get better. Alright, imbalance. Okay, yeah, it's this difference between, oh, Jesus. Yeah, it wrote a minute ago, and now it doesn't write. Okay. Between electrons and protons. And so, because these things exist, let's not talk about why they exist or how they got into existence. They exist. And they're doing two fundamentally opposite things. So, when a black force hits one of these red things, okay, it just deflects off. Like if it was a boat and it had a point on it, it's like the red things go this way or they go this way. You know, they don't make an exchange. So there's no seat on the boat makes an exchange with the black thing here. Okay, so it just says you're the wrong color and it throws the guy off the side of the boat. This side, are in and out. Same thing with the red hitting the electron. The electron just says, screw you, you can't stay in this boat, you can't have an interaction with me, I have nothing to do with you. So anyway, so when this happens, obviously you can see that force going this way is now going this way. Okay, and so now the universe has changed because something over here that was minding its own business, and this force had no chance of hitting it, so it's going to get hit. You know, it's in the universe, it's going to get hit by a certain amount of stuff, blah blah blah. I'm minding my own business, I'm going to get hit with a certain amount of stuff, and all of a sudden now there's more stuff coming this way. So it's changed the field, okay, around this object has now been changed because way over here, 10 billion light years away maybe, a piece of force diverted on the boat and ended up now going to this guy. Now this guy's going to get pushed a little. Alright, so, I mean, you know, red force does the exchange part, you know, so just black force does the exchange part with the black, so I'm not going to go through all those details again. But anyway, so you can see that that diversion of the original path of the force is why the matter is making the universe interesting. It's changing it. And so if you have a few of these protons in a row somewhere in a certain arrangement, you could see where they could end up putting a lot of extra force going one way right towards this guy and cause him to have momentum. And then when he has momentum, that means, again, he's going to change the universe for this guy. You know, one thing can't move without changing the field, in the sense that the field is the rowers in the free ocean. And the rowers in the free ocean changes as you arrange protons and electrons in different patterns. You change the rower field. It's just so simple, and I just don't, you know, it doesn't take, I'm not asking much for you to be able to follow along. It's a simple analogy. Rowers swimming all the time, always, and when they get in a boat, they swim the same way they got in, you know, they were swimming. And the only thing that changes is if you're the wrong color rower and you try to get in the wrong boat, okay, you get kicked off sideways and you just keep swimming that new direction. And the whole thing is built out of that. That's all you need to make the entire complex universe. Alright, anyway. Let's see, we're energy. Okay, and do you really think people are smarter today? Of course I don't, so I don't know why you say I would say they're smarter. I think they're incredibly dysfunctional logically, and obviously I've done all I can say about dissing how bad the scientists are. They have no discipline. Science has no discipline anymore. They keep making, I mean, if it wasn't for the few dissidents there are, even NASA makes colossal scientific errors, you know, where they did that whole research program with the arsenic and the, you know, creating a life form, a new form of DNA that, you know, had arsenic in it, and, you know, it was a complete pile of crap. So lots of bad sciences go sliding right under the radar because the logic radar has gotten so poor. And part of it I don't blame on people. Okay, it's really hard to be smart nowadays just because there's a lot bigger world to understand, a lot more information. It's like this Bill guy at the other place that says he knows everything essentially. Oh yeah, I wrote the most brilliant compression algorithms ever, and I wrote the first multi-processor software, and I did everything. It was really hard to do everything nowadays because everything's really complicated. Just being able to fix something, you know, like a printer is now different than a dishwasher and this, and you know, it's not the same world. And you have to know a lot more to appear smart, I guess, or to be categorized as smart. You can only be a specialist now. And if so, doesn't QM deserve a little credit? So, credit for what, you fuckhead? I mean, you're just reading off of Wikipedia pages or something, or out of the propaganda. QM is nothing. QM, they'll say to you, oh, it's the Schrodinger equation. Well, go look up the Schrodinger equation and see if you can find something magical in it, like a wave or something. But it isn't in the equation. Okay, the only thing in the equation is distances and masses and lengths and that kind of thing, and velocities. There's nothing magical in the fucking formula. And there's a thing called a frequency. Okay, that's not a wave, that's a frequency. Okay, that's how often something happens. For fuck's sake. I personally hate Ken Wheeler. Well, I don't care. And can't listen to him. Well, that's whatever. Your problem. But I do think Sean Carroll, maybe Brian Cox, has some good things to say. Why? Because they have hair like yours or something? I mean, I'm imagining your reasoning is very superficial. Because you like their voice more, or some other kind of horse shit. Because you don't know anything. You know, you're just playing along like you've done the work, where you've spent hours listening to physics lectures and you understand the concepts of resonance and reflections and all this kind of stuff, and you don't. It's not about believing physics is a fantasy. Well, fuck you. It's about making the accusation that their concepts are fantastic. Okay, bent space as a concept is fantastically vacuous as an explanation for anything. It can't happen in 3 dimensions, first of all. It uses the force it's explaining as an illustration. You can't really understand how bent space means anything if you don't understand gravity would push it down the well. I mean, a well doesn't mean anything to you if you lived in anti-gravity and there was no falling down the well. Then the well wouldn't mean anything, would it? No. So they're using the very force to illustrate the force, which is so circular. Then when they do it mathematically, it's just fluid dynamics. Stuff comes in out here, and it goes down a drain in here in the middle. That's how simple it is as mathematics. So just quit pretending you know something about this shit. Let's see. The ideas in QM are concepts that, if understood correctly, how the fuck would you know what correct is in terms of understanding? Exactly. Why don't you give me your history on where you've done any research at all besides the most superficial? Watch the Dr. Quantum video. Just create rules in a deterministic universe, in my opinion. Well, clearly there's no determinism in Richard Feynman's universe, okay? Because he thought the randomness was epistemic. It was just part of the universe was playing dice. And if you don't like it, tough. I'm not hating. You're retarding. Okay, but obviously physics has issues and science in general as well. Well, you say obviously, and well, why don't you detail those? I'm saying the obvious errors are in the elemental concepts. Wave-particle duality is an idiotic concept. Okay, it's wrong on its face. It's a stupid place to start. You're already dead in the water. And bent space is the same kind of nonsense. The actual mechanism is not a bent geodesic. Things don't move because the magic geodesic says so. Everything moves in this fucking universe because something real interacts with it. However, it's authentic education, but it would be good to know both sides like you do. Well, yeah, what's the both sides? Yeah, I know my side, and I happen to know their side. My argument to you is that I don't think you know enough about their side or my side. Or maybe they do know the foundational principles. I just illustrated how they've chosen very bad foundational principles. Wave-particle duality mixed with something called a virtual photon that can either pull or push. And they don't know why it does one or the other. That's hardly an explanation. Why do magnets attract and repel? Because there's a thing that attracts and repels. That's their explanation. It truly is that bad. And so why do I need to do any of this conversating about how, yes, it's all kind of BS. Physics is BS. If they can't answer these fundamental questions, how can they answer the more complex ones? I mean, it's that kind of simple logic here. I mean, they can't tell up from down, and they're going to tell you, you know, complex vectors. All right, and they're just choosing to ignore them. Yes, they're choosing to live in their delusionary, fun universe of complexity and wavicles and magic and mystery, and math, as if math is a model when it's not. It's merely a formalization of what you already know, and in some ways a complexification, right? If they could put math into, instead of using the silly symbols they use, if they used emoticons, the game would be over, because everybody would start to understand emoticon, you know, for wavelength, and emoticon, you know, something instead of this silly lambda crap and theta crap and beta and alphas and all this other shit. If they made it real, so you understand distance is distance. It's not that complicated. The D, that's just distance. It's not that complicated. I still want to buy Sean Carroll's and Dawkins' new books. Well, good for you. Go buy some books. Hopefully scientists can just automate your personality before you die, so we will have a glimpse at the truth before everyone is an imbecile. I don't even know what to say. I'm sorry, you don't need a computer to figure out wave-particle duality. That's a contradiction. Fuck it. It's stupid. Try again. Or someone takes your place, which I doubt too, and such. Yes, well, they can go ahead and take my place, but I've already done all the fucking work. Not that, you know, not that the nuance don't need to be fixed. I mean, somebody will probably figure out that it's all one thing, like the two forces aren't really red and black, they're just on different planes in the universe, so they usually don't interact at all. But because of the protons are essentially pushing the red force into the black force's geometry, and you know, blah 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 blah. It's probably little extra things like that. All right. Sorry, I mean, I don't mean to be rude, Tyler, but you know, this is kind of it's not to my purpose. I need to argue the real physics as real physicists believe it. You know, follow the lack of parallax and star trails. Well, that makes just no sense at all. So this is a Ken Wheeler lover. And of course, he has a sideways icon, because that's the only way you can make any sense of Ken Wheeler's bullshit. Buoyancy, dot density, and electromagnetism, which again doesn't mean anything. Electromagnetism is magnetism. There's only one thing, magnetism. There's no such thing as electromagnetism like it's different. It's the same fucking thing. Alright? So, this is such bullshit. It's like your dielectricity. There's no dielectricity. There's a dielectric. And there's different ways to make something magnetic. Okay, you can put a current through a coil of wire into a hunk of iron and make it magnetic, or you can do it in these different ways, but it's just making it magnetic. Okay, magnetic is the only thing there is. There's not electromagnetism. You're just describing how you cause the magnetism, which is totally irrelevant to the magnetism. Fucking people. So another loop-de-doo icon person. Dream Eater. The problem with your videos is that you don't understand his references. So this is another Ken Wheeler pile of shit. Now, of course I do. I know what a tornado is. Okay, I know what hyperboloid is. It's a lot of wavy movie bullshit. And then I also know what a coaxial cable is. And then a photon ain't no fucking coaxial cable. As you often say in your videos, what does that mean? Yeah, you only study what you believe. So this is just more crap. I'm obviously studying Ken Wheeler. Do I believe any of what Ken Wheeler is saying? I'm studying it to try to figure out why people are this fucking illogical and so full of shit and so deceptive and so dishonest. I'm studying his dishonesty. He studies what he believes. No, he doesn't. I don't think he studies anything, frankly. And what you believe, he doesn't study evidence. Okay, if you study the experiments and you try to explain them, where does he do that? Where does he take an experiment that's actually real in physics and explain in any way whatsoever? It doesn't explain anything. And what you believe to properly debate you. No, you can debate basic assertions. When somebody says light is like a coaxial cable, I respond with, how so? You know, where's the shielding? Where's all this stuff? Do you mean it's the light is still connected to its source somehow? You know, that it's a complete circuit somehow? Well, where's the evidence of that? Why do you believe that? What piece of evidence, visible evidence in the universe, makes you think light is doing any of that shit? That it isn't just something in space and it moves through that space. I mean, whether you want to call it a compression in the jello or a wave in the jello, well, a wave in the jello is not anything like a coaxial cable. Do more research before you argue your ignorance. Fuck yourself in the ass until you're fucking good and dead. I mean, that's just obnoxious. Alright. Soon to be blocked, I guess. Waving in, waving of. A wave is an action of a type of medium. A wave, the word wave, was clearly invented because we saw the fucking things. We saw the lump moving. Okay? That's a wave, fuckhead. That's where the word originates, is that we saw the lump moving. That's a wave, fucker. You want to sit there and play this game that you're going to redefine what wet is next? What other words are you going to tell me what they mean? Fuck you. Something cannot by definition be a wave. Well, clearly the blob of stuff moving can be a wave. Now, understanding what the wave really is, just like the bent light in the supercell, understanding what's really causing the wave, okay? Yeah. That might you might be deluded, and you might think that the same ocean water is just moving across. You know, you might think it's the same molecules that are going across the ocean. No, it's not the same molecules. New ones are getting pushed up. The old ones pushed down. Pushed up, pushed down, push up, push down. Okay, as that is the action of said thing. Yeah, fuck you. Light can't be a wave itself. Who says it is? When somebody says it's a wave, they're clearly saying it's a wave in something. So again, who are you preaching to, retard? It's a wave of something. Yeah, something. What would the something be? And what's your evidence of something existing? And what's your evidence that the somethings can somehow make waves that are perfectly just like a torpedo? Why don't you show me a wave in nature that looks just like a torpedo? Why don't you show me one of those? Fucking cunts. Fuck off. Douche. Eat shit, Dream Eater. Yeah. Dream of shit and eat the shit. Alright, why? Fuck you. If you hold these things upside down, the color runs out of the tip. Oh, thank you. So if I hold it upside down, so I'll just do that all day, right? I'll just hold it upside down. and all the liquid will run out, you're saying. I don't think that's going to happen, but whatever. If you leave the cap off and hold it upside down, the tip dries out. You think that happens too. So if I hold it upside down, you're saying the cap is going to fill with fluid. And if I take the cap off and hold it upside down, you're telling me the tip will dry out. Yeah, I get the concept that the tip can dry out. I get the concept that the crap has to flow through the thing, and it's, you know, gravity will help. So maybe store them in this position would help. So I'll put it so it's stored in the proper position. Alright, so you could give me some useful advice, but this crap, sorry. Accidental scientist, what the hell is that? Let's see what's on his channel. Bad day. Bad planet. Oh, no content. Oh, there we go. An accidental scientist. Let's see what videos he's got. I did see a black hole. Oh, hell with that. The models of mod Acnid Science 1. I don't know what that could possibly be, but I'm curious. So let's play along.
Alright. This is for my patrons.
Oh, Patreons. He has patrons. He has 3 subscribers and a Patreon page.
So what I gotta do is bring the camera a little bit closer. See if I can...
Yeah, look, he's got something behind him, right?
see if that helps.
Look, I'm doing something. Sales,
what this is
scales.
the what I've now named something called an AOT MOMAS, an out MOMAS, which is just an assessment of the models of modern academics.
You know, tin baseball caps. I guess will have to be the next, you know, rendition.
Science, an AOT MOMAS. And what I got to do real quickly here, because this is only going to be a short video, and it's only going to talk about why we need this thing. Hey Mark, you know, why is this needed? Secondly, you know, why these models? Why these models over here? Nope. Why those models over there? You know, why these particular ones? These particular ones here. There we go. And why this structure, namely, you know, why have I got, there we go, why have I got here, you know.
Categories. Yeah, I know, you got categories. Pressure, examples, can't read what it says, evolution, I don't know, elevation maybe, yeah. I don't know what you're really analyzing here. Invalid premise, invalid something, assumption, invalid. Yes, there's lots of invalid. It's an assumption. Energy is. Yes, well, I've already explained that. Order, effect, and the energy is just the imbalances being created by changing the path of the force.
What have I got? A subject, you know, what it explains and what process it uses. And then why have I got here, you know, a set of assessments, and why these criteria, that's actually number 5, is why these criteria, why these titles, why these columns, why these criteria, why this structure, and why this organization.
Well, look, I applaud you for trying to organize stuff, but yeah, I'm not too sure this is the way to organize it. This looks like a bad version of the periodic table. I don't think it's quite what you need to analyze and, you know, rigorously point out the flaws in these different theories. I mean, you could do a whole chart like this just on the 2-slit experiment and all the wrong assumptions and the facts stated as facts that aren't facts, like the fact that they never did any of these experiments trying to detect anything. And that they could, in fact, do these experiments trying to detect buckyballs, because you wouldn't change the path of a buckyball that much by hitting with a single photon.
But here, namely, why are these ones? Why are these ones together and those ones together, and why are these ones with this ones? And so I got to explain that. But these are the primary models of modern academic science, and so
Yeah, they really only have the two models, bent space and quantum mechanics in the terms of the virtual photon and the wavicle, you know.
in a sense, we can look at these and say, well, you know, here's what we got for our money. Here's what we got for our money. And here's an assessment of them behind my head. You know, and here's sort of what they...
Yeah, well, too many words is no good, too few words is no good. You're definitely on the too few words here. There's more to the broken than you got in this. You know, you got to use more than 6 words to point out the wrong.
You know how good they are. But here's what they say, right? This is what they say about that. This is what they say about that. This is what this one says about that.
Oh, his is evolution, I think. Well, what do you how you can't be dissing evolution, you retard. So you're already turning me off. You think there's any evidence that evolution isn't a fact, then you are just too fucking stupid. Alright, anyway. Just so you know, I'm still watching these, Superior Mind. Still very intrigued by your developing elaborations and the very gradual impact it's starting to have. Yes, winky face. Yeah, well. Yeah, the impact is on me. I'm just realizing they're way too stupid, Gary. There's just no point. They're all too frickin' stupid. And the wise monkey, hey Gary, tell you what, dude. Yeah, just go ahead. Make my day, fuckhead. With your jargon. Ugh. Shit. How does your explanation of magnetism, this is Tyler again, explain why the star... Oh, fuck. Stars don't have anything to do with magnetism. Isn't visible in the Eddington experiment until you distort the picture. You're just an idiot. I'm sorry. The star is visible. It's in the wrong place. The theory is, instead of the light going nice and straight, the light has a curved path, which means when you see it in the wrong place. If you follow the curve, right? The last place it was going when it hit your eye, right? So if I go over here and I curve the light from the camera, right? The last place the light was going, the last angle, is the angle I'll see the camera at. So the camera, I would, if the light curved, I'd see the camera over there instead of where it is over here. It wouldn't disappear. The disappearing part only happens in the sense that, you know, the idea is you're seeing something because it's curving around another object. So obviously you wouldn't be able to see it if it's behind the sun, but you can see it because it's curving around the sun. The light is. So, I mean, you really don't know anything about the Eddington experiment. I understand there can be a different pressure to let you see certain visible light. No. Fuck you. You understand? No, you don't understand. Again, you're just... Go ahead. Believe any kind of fairy stories you want, okay? Go read some crap on the internet and believe it. I can't help you. If you're going to believe every claim by every idiot, I can cure this, I can cure that, I got a cure for, you know, then you're a dupe and a sucker. I can't help you. I'm not saying photons traveled into the future. Jesus Christ. But I am saying that it seems to be a paradox of physics. No, there's no paradox. Is it a useless experiment? It's useless because, first off, it can't be done because the amount of bending is so tiny because photons are so fast. And so there's no math that can rescue you from that. And then Einstein just made up fake math in the sense that he made up this fake notion that photons are twice as affected by gravity, not magnetism, gravity, all right, than anything else in the universe. And he just did it to make it almost possible that you could see this effect. But it's still really hard to see. So, yeah, and if it happens, So it's a real marginal experiment in the first place to do. That's why nobody does it, because it's so fucking marginal. And I'm clearly arguing, if you haven't figured it out yet, it doesn't fucking happen. There's no evidence that photons are bent by magnetism or anything electrical or anything gravitational. There's just no fucking evidence they do anything except go the speed of fucking light in a straight fucking line until they hit a fucking electron. Then they go in a new direction, like the surface of a piece of glass, and then the light bends into a new, different direction because it hit something. Not because it hit nothing, because it hit something. I thought the truth had to be simple, but I still can't wrap my head around the Eddington experiment. Well, if you think it's about magnetism, you're way off. Northern Lights, a lot of things. Northern Lights are a completely different subject and have to do with what the sun is expelling, and the very fact that it is kind of stupid to talk about how you're going to see light bent around an object that is producing so much fucking fog. Okay, there's a fog around the sun, a fog of energy that the sun's producing. It's invisible smoke, or however you want to look at it, but there's a ton of little bits of shit that the sun is expelling because there's a bunch of nuclear bombs going off, essentially. So there's a whole bunch of crap flying out of the sun, and they call it its corona. Well, even past its corona is a ton of shit flying through the solar system, and some of that's called the solar wind. The solar wind is made up of a bunch of tiny little atom nuclei and shit that are still intact, but they're all ionized and in hot plasmatic kind of condition, and then they hit the crap around the Earth, the atmosphere, the upper atmosphere, and as they hit those particles they release photons, the energy blah 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 of the impact, and we see it. How can you, what's so hard to get you wrapping your head around that? Enough for now, I guess, till next time. And the idea is if the reason why those ions can hit the ions around the Earth is because the ions around the Earth are in a magnetic field. So that's how they associate it with the magnetic field of the Earth, is that the magnetic field is essentially all those little ions are lining up like iron filings. And so they create a little bit of a barrier of crap around us that shield us from the sun's wind. That's the simple version anyway. So bear in mind, thinking about trapped force, yes, you might have said something like this already. I realized the trapped force wouldn't necessarily need to be maintained as the same trapped force that originally entered the trap. Yeah, it's sort of irrelevant. I mean, this is all has to be, I mean, it's the complexity of the trap, right? The electron is essentially a trap. Force goes in and it doesn't come out until it gets exchanged. So you have this capacity to have an imbalance in the trap of the electron, you know, where there's more stuff that came in this way, you know, even though it's just bouncing back and forth, it came in this way, which always matters. The first move is always the move you never undo, because, you know, reflection. So it's still in there. It's still in the trap. So in an ideal circumstance, I could have a little car on wheels, and you know, with a bucket on it. I could throw something into the bucket, and the car would roll because I threw something in the bucket. But it could bounce back and forth inside the bucket, and it would still move in this direction, in the forward direction, if there was no losses. Because this action never gets undone. So it will go, and then it'll go back, and then it'll go, and then it'll go back, and then it'll go back. But it'll always go more than it goes back. Kind of thing. Trapped force that originally entered the trap. And by trap I mean the configuration of elements, such that they have a certain battery-like capacity to trap reflecting force as you described before. Yes, battery's kind of a good example, just in the sense that you're obviously in a battery creating an imbalance. Okay, you know, a lot of stuff wants to fly out of one end and nothing wants to fly out of the other end, kind of thing. What I mean is there exists a capacity. I mean, all the fish in the battery are sort of swimming one way, and they want a pathway. You know, they're trying to get out the negative end, actually, and the pressure, and they can't get out until you provide them with a river. And so the river's the conductor, and then they can flow through the conductor. But if the river stops somewhere, then they can't go anywhere, and they're still stuck. The pressure still exists. So, you know, you have to let them out eventually. All right. And the force leaves it. Let's see. What I mean is there exists a capacity for a certain volume of rate of reflections based on configurations, and if the force leaves the configuration, it won't matter because the imbalance or equilibrium would stay the same. This is where it gets tricky. It's like the Earth argument in gravity. I can feel the difference of the Earth shadowing me from force. So there's a bunch of force coming towards me, and we stick an Earth in the way. And so now that force doesn't hit me. That's easy. But the trick is the Earth is also absorbing the stuff going this way. But frankly, I don't see any of that stuff. See, I'm small compared to the Earth, so most of the stuff is hitting the Earth still, going that way. And it's absorbing that too. But how could I possibly know, right? It's absorbing stuff that never hit me. How can I know? Because it's still going that way. I can't know. So I only know about the stuff it absorbed going this way. And the stuff it went that way, I don't know anything about that. I can't sense that. I can't see that change. That change can't affect me. So I'm only affected by one part of what the Earth is grabbing. So if you understand that the junk inside of the Earth is spinning, you know, rotating, moving in all these directions, swirling. It swirls as much this way as it swirls this way, just from being hot. And the only part of the swirl that matters is the part going this way, because that's the part that absorbed the energy that would have hit me. That's the part that's the mirror. Okay, let's see. It won't matter because the imbalance and equilibrium would stay the same. So even when you're at an equilibrium, a state of equilibrium, the Earth is at a state of equilibrium, but it's still creating gravity to any object from any location, because that object will only see the difference the Earth is creating in one direction. It won't see the difference in the other direction. And thus the force is replaced from external equilibrium by opportunity. Yeah, photon goes in, electron moves, new photon exits. I mean, it's all, the pathways have lots of change your partner, do-si-do going on, but it's really this, even through all the do-si-dos, it's still, something's moving from here to there, so to speak. Really all it is a potential amount of energy based on what can remain trapped. And again, the trap is only trapping, it's only collecting imbalances. So to be imbalanced, to be 3-2, means you left a 1 out here somewhere. Okay, and if you're 3-2 the other way, then you left a 2 out here somewhere, you know, one of the 2 chitin. So, I mean, there's always balance in the universe, and all you're doing is creating elements or pieces of the universe, places in the universe where it's imbalanced, because you've trapped something in this, or this, or this. And it didn't get where it was going to create the balance. Somewhere it didn't get where it was going, and it would have been balanced if it got there, but it didn't get there, so now there's an imbalance there too. So you not only have an imbalance over here, you have one over there. If I have an imbalance on the boat, it means the field, the rest of the universe, has an imbalance too. Alright, I guess you could say that it has a lot to do with imbalance. There you go, which seems to be what you're getting at. Yes, that's why I keep saying the word imbalance. And the time it takes for the collection to communicate that imbalance across the little distances. Yes, little big distances, little distances. the balance will be felt in some amount of time, depending on how far things are apart, and then time becomes important because, again, distance is time, and distance is also energy in the sense of how much you've imbalanced out there, right? I mean, if I have something bouncing from here to here, and the whole universe is that size, here to here, then there's no imbalance. But if I cut this piece to going here to here, well, then this is very imbalanced over here, but nothing's going over there. So the two things are now imbalanced, and all the imbalance is in here. And if I do it again, then I create even more imbalance here, and an even bigger place that's imbalanced there. That kind of thing. All right. So, I mean, the closer I bring two things together, the more isolated I've taken one force that should have spread across a whole lot of universe, should have experienced a whole lot of universe, and it's only experiencing this part of the universe. So there's a whole part of the universe that's not experiencing it that should be. So the closer things are, the more imbalance I'm creating, both in between where the things are and in the big part that's now missing a whole bunch of experiences. So this was on a Ken Wheeler video, I think, also, this comment. Yes. Sorry, buddy, but you get entangled in your own ropes like a drunk spider and don't really get to explain this in a clear way. I mean, whatever that means, compared to Ken Wheeler's explanation. So if I really asked you to explain what the fuck Ken Wheeler means by coaxial cable, you could do it. You could tell me how photons are just like coaxial cables. You could do that. So this is some jackass writing on some chick's picture. Just liked videos, nothing more. Complete crap, no doubt. Oh, there's a Theoria. See, he likes all this little girly bullshit, little swirly girly bullshit. You know, he wants fairy physics. Ugh. What else is in here? Oh, Bill Moore. You know, he's a great physicist. Violoncello. Well, classical music's good. All right. Oh yeah. So Walt Disney was Adolf Hitler, right? Yeah. I wish, frankly. But whatever. You know, I wish there was a cool Hitler like that. So anyway, fuck you. And until dead and such. Alright, it's probably enough. I was going to make a contrast between conventional physics and my physics, but I can do that in a separate video, no doubt. And probably is a better use of my time. I don't know. There's probably no use. There's probably no better use of my time because I'm on a planet of turd. And you just can't make anything out of turds. They're just have nothing else on their mind. Be a turd, be a turd, be a turd. Okay, go ahead, be turds. I don't care. I do care, but I mean, there's nothing I can do about what you decide to be. You want to be stupid? Continue to be stupid. You want to be a dupe? Continue to be a dupe. I mean, you're obviously doing it on purpose, because I've given you every reason to stop doing it. Fuck.